Hello, my name is Marcus from Gigahertz Solutions. I will briefly explain the operation of your ME3951A after you have received the order.
In addition to the measuring device, you will find
a charging device for the internal battery, a grounding cable for potential related measurement, an additional grounding clamp, and this small card of the building biological reference values, the calibration confirmation, and a manual of use included in the package. On the meter, you can see the display down here. Here is the battery check button with charge control LED and the frequency switch of the internal filter. On the right side, you see the power button, the signal switch, and here above the jack box to connect the grounding cable. On the left side, there is the connection socket for your charging cable. Right below, you find the measurement range switch and two other jack boxes for external outputs DC and AC. There are no other switches or plug-in options above and below. On the back, you can see the two serial numbers of the ME and the internal filter along with our logo. For measurement, you only need to push the power switch one position up. Measurement starts automatically. You have the option to turn on an additional sound signal by placing the power switch upwards. So you will hear a field strength proportional audio signal similar to a Geiger counter. If high field strength is detected with a large load, the sound is very fast. With little field strength and less load, you will hear slower sounds. You can change the signal selection here at the top. When the top position is set to E, the bar at the top of the display will appear on E for electric fields in the unit volt per meter. If you switch all the way down to M, the bar below also will move to the section M, and we measure magnetic fields in the unit nanotesla. Measuring is generally taking place only in one dimension, meaning for the total load we would have to measure all three spatial axes. So first, you take a measurement in this position, notice down the value. Once in this position, memorize the value again. And finally in this position and once again, note down the value. Quadrate all three measurements, add them together and draw the square root to calculate the actual three-dimensional load influencing us at this very place. This works magnetically as well as electrically. For magnetic measurement, you can simply hold the meter at the bottom and walk freely through the room. It always is measured along the y-axis, always away from the device. Magnetic and electrical sensors are located here, in this area on top. There are two options for electrical measurement. One, potential-free, meaning you place the meter down at the spot you would like to measure and move away from it, so as not to affect the E-field. The second option is potential-bound. For this, you plug your grounding cable into the jack box here and connect the device via the crocodile clamp to a grounded point, such as the protective contact of a plug-in socket. This type of measurement is excellent to localize sources of stress. So you can hold your device down here again with it meandering forward into this direction. Move freely in the room and move to or away from sources and see the different measurement results on the display. Between electrical and magnetic fields we have built in the test function. That is a control for you to check the deviation of the device. Ideally, you should see 3 times 0 on the display. The battery condition is checked by pressing the button here. All segments of the display are brightly illuminated. If they fade a little after a while, this indicates the battery should be recharged. This is done by simply turning the device off. Plug the charging cable into the device and your plug-in socket. And if charging properly, the control LED will light up. When the device is fully charged, the LED will turn off and you know you can continue measuring. Via the measurement range settings, you can decide if, for small measuring values, you want small and delicate settings. At least you have one decimal place and a more accurate measurement result. The maximum display value here is 199.9 depending on the choice of signal, nanotesla, or voltmeter. If the shown value on the display is not enough, simply switch a position down and you have the large measurement range with a maximum display of 1999 nanotesla or voltmeter. Through these two jack boxes, additional external signals can be captured. For the AC box, for example, the connection of an oscilloscope would be possible. The internal filter works electrically as well as magnetically, meaning if the switch is positioned here at the top, the full range of the meter is active from 5 Hz to 400 kHz. Absolutely everything is being displayed. The second switching position at 16 Hz would be ideal for rail current, for example. All rail current systems run at 16.3 Hz, and the proportion I am currently measuring here is in the measurement result with electric as well as magnetic. If I want to cut off the rail current, I switch a position further down, and here you can measure 50 to 400 kHz. All signals that are interferences stemming from rail current are therefore excluded and would no longer be on my measurement result, just as the last position for upper waves, dirty power, from 2 kHz up, everything else is also cut off. I hope this video has helped you to measure safely and correctly with your ME3951A in the future.